So with our last video, we'd found this class of numbers that after two steps through the odd Collatz function turned into a power of 2. And we'd sort of looked at them a little bit, and we'd noticed that based on the information about our pattern from the first odd step, we could sort of start assembling a number that behaved in a certain way. So I want to look a bit more closely at these second numbers and talk about some patterns that pop out of it. So the first thing you might ask is, we saw this pattern 1 0 1 0 1 0 1 for the first odd step. It turns into a power of 2 after you triple it and add 3. So if you're thinking a bit about this, you might ask, well, is there a pattern that turns into 1 0 1 0 1 after I triple it and add 3? Is there a binary pattern that behaves that way? And there is. And I'll just give you a quick example of it. But if you go 1 1 1, 0 0 1 1, and then I'll chuck a 0 on there so that I'm doubling it. And then I'm going to, so this is our 2n line, and this is our n line, and let's recall 2n plus n is equal to 3n. And so if you do the binary addition here, right, you get 1, and then 1 plus 1 is 0, and I have to carry the 1 over, right? And then I have 3 here. I have 1, 1, 1, so I get 1. And then the next one, I've got 1 and 1, and then I get 0 because I add those. And I've carried, so then I have 1 because I have 0, 0 here. And then here I have 0, 0, so I get 0. 0 plus 1 is 1. 1 plus 1 is 0. I'm going to chuck a 1 up here. Then I'm going to get a 1 down here because of the carry. And then, I've got one more carry here. So I got 1, 0 on the front, right? So what I have here is a pattern that if I triple it and add 1 turns into this pattern. So now we can start to think about breaking up our number, right? We can start to think about turning the number into parts of the number that behave a certain way through the odd step. So I'm going to take 113 in decimal, and then in binary, this number is 1 1 1 0 0 0 1. So this is our first part of our number, right? These are the zeros that are going to be generated. We're going to get 2 zeros from the first odd step, right? And then the remainder of the number is going to come from the second odd step, right? And so if we look at our first pattern, when I'm deciding how to end this pattern, like say I want to assemble a number that behaves a certain way under the first turn through the odd Collatz function, and then it behaves a different way under the second turn through the odd Collatz function, I have this pattern of 1s and 0s, right? And say I want 3 zeros after my first turn. I want 3 divisions by 2 after my first turn through. Well, then I just want 1 0 1, right? But if I want 4, then I want 0 1 0 1, right? If I want 5, it would be 1 0 1 0. But where I cut the pattern here, where I slice through and end this first string of digits, determines it has consequences for my second pattern, right? Like if I have 1 0 1, to break the pattern here, to end the pattern here, to stop it, I have to chuck in a 1, right? And if instead I have 0 1 0 1 because I wanted 4 digits, right? Well, then here I have to chuck in a 0, right? So the key digit that breaks the pattern isn't always the same, right? It could be different. So you can see with 113, right, we have an example of the first 2 digits, 1 and 0, it ends in a 0. So to break the pattern, I need to add a 0, right? And so even though you have the sequence up here of 1, 1, 1, 0, 0, 0, 1, 1, 1, that repeating sequence, the pattern doesn't always, the way you add the patterns together is contingent upon how many digits you included in that first step, right? Where we place our new pattern changes things. And it's even more complicated than that. I'm not going to go into too much more detail in this video, but you saw, that a lot of the reason this pattern here turns into this alternating ones and zeros is because of this cascading line of carries up here that flips bits, or flips these binary numbers, flips the ones and zeros in a way that that produces the pattern that we want. So you have to start taking into account this third line, right? This third carry line, to make sure that you understand how the number is behaving. And it also limits what you can do. You can't just design an arbitrary number that says has 5 steps in the first Collatz behavior, and then first odd Collatz function, and then through the second step it produces 2 zeros, and the fourth step it produces 5 zeros, and then it finishes on the third step through. There are consequences, and the number extends out and grows out as a result of these interacting bits, as a result of these flipping ones and zeros. So hopefully that's clear. If there are questions or things aren't making sense, please ask questions and I'll try and clarify them. But for the next video, I'm going to sort of take a break from talking about these patterns of steps, and I'm going to move into talking about trying to place limits on how this carry line, how this flipping of ones and zeros controls the growth and the shrinking of numbers under Collatz.